Okay, so we have learned that acids are sour and bases are bitter. We can't taste every substance, right? It's not safe as well. Then how can we identify? Let's just imagine I'm giving you a substance and asking you to tell me whether it is an acid or base. We can't taste, right, everything. It's not safe as well. So how will you identify that substance is acid or a base? What can we do?
Sometimes soap is like acid.
Yeah, one
Ma'am,
by
by
one.
seeing properties of the substance, ma'am.
By seeing properties. How can we see the properties? How can we check that?
By using indicators.
Yes, Muhilan. Yeah, you were right. Yes. So here comes the role of indicators now. Okay. So
Ma'am, litmus paper.
yes, very good. So just like your bike has an indicator, right? We have seen indicators in the bike. Why do we have that?
To indicate to others that we are going in a direction.
Yes, so that is helpful in that way, right? Just like that, indicators in the chemistry here, it helps us to know if a substance is an acid or a base. Okay, so to identify whether a substance is an acid or base, we will be using these indicators. So these indicators we generally have in two types. One is the natural, yes, one is the natural one, the other one is synthetic indicator. Okay, so these are the two types of indicators we have. Let's start from the natural indicators. Can you name any of the natural indicators which you have learned in your lower grade?
Turmeric.
Turmeric, yes. Anything else? Any other indicators?
No.
Yes. So we have here, right, which you said first, litmus. Is it natural or synthetic? What do you think?
It's natural.
Yes, it is natural indicator. So this litmus is the most commonly used indicator. Okay. So how do we get this litmus paper actually, which is made from the natural dyes found in the lichens? Okay. Yes. So from that lichens, we are actually getting this natural indicator dyes. And when you dip a piece of litmus paper into the solution, which we are not aware whether it is an acid or base, if you dip that litmus paper, example, we have two colors, right? What are the two colors of litmus paper we have mainly?
Red.
Yes, blue litmus paper and red litmus paper. We have two colors. So mostly this is a common indicator which we are using. So if the litmus paper turns red, you can see the blue litmus paper, it turns red. So how can we say that?
Acid.
Yes.
It is.
Very good. So if the litmus paper turns red, it is an acid. Okay. So you can see the blue litmus paper, it turns to red. It is an acid. And what do we have here? The second one, yes, red litmus paper, it turns to blue. How can we say this? Base. So everyone is clear with this color change, right? And if it stays same, the blue litmus stays blue and the red stays red, how can we call them? Neutral. Okay. Anyone have this confusion? We also have recalled this in our first chapter, right? Sorry. One more time. Yes. So how do we remember this? These colors, it can be tricky, right? We will be using some memory tricks to keep it clear. Correct? What is the trick we have used? Very yes. Yes. And for acid?
Acid dangerous.
Dangerous. Yes. So that is how we remember, right? So we have to check for the color change. Change color da paakano. If it is red, it is acid. Okay. So if it is red, it is an acid. We know, right? Red is often used for something dangerous or to warn something. We will be using that, right? So especially when you're handling with the concentrated acids, they can burn our skin or it is quite dangerous. It's like warning, right? So you can remember like this. If it turns from blue to red, it's an acid, and red to blue, Red to
It is
blue, how do
base.
we say it? Yes, it is a base. Okay. So change ஆகிற கலர் தான் எப்பவும் பார்க்கணும். இங்க B இருக்கு. The same way here we have B, right? So the first letter,
Ma'am,
both start with the letter B, so you can remember like this. Yes.
yes, ma'am. For example, we are having a red litmus paper and we are putting it in acid. What will happen, ma'am?
Sorry, come again.
If we have red litmus paper and we put it in acid,
Yes, red litmus paper, if it is an acid, it remains the same, right? The red color will remains the same if it is an acid.
okay. Okay, ma'am.
Okay, so this is the change we have to remember actually. If it is a blue litmus, it turns to red, it is an acid. Okay, if it remains the same, if the blue remains the same blue, it doesn't actually with neutral solution அப்படியே தான் இருக்கும். Even நீங்க இதை வந்து basic substance use பண்ணாலும் it is the base, it remains the same, it will not change any color. The same for red. If the red litmus changes to blue, we say that as a base. If red remains the red, நீங்க அந்த எடுத்திருக்கிற சப்ஸ்டன்ஸ் வந்து ஆசிடா இருக்குன்னா அது அப்படியே தான் இருக்கும். அண்ட் ஃபார் த நியூட்ரல் சப்ஸ்டன்ஸ்க்கு ஆல்சோ இட் மே பி தெர் இஸ் நோ கலர் சேஞ்ச். கலர் சேஞ்சால யூ கேனாட் ஐடென்டிஃபை தட். இட் வில் பி த சேம் திங். ஓகே. யா, எனி அதர் டவுட்ஸ்?
No, ma'am.
No. So there are actually many other natural indicators as well. One is we have seen about the litmus paper. So the other substances like red cabbage leaves we have here, right?
Then
Yes. Any other natural indicators can you say?
rose,
Yes.
red cabbage, turmeric, China rose, phenolphthalein.
Yes. So we have all these indicators. They actually help us to know the presence of the acid or a base. So we have red cabbage leaves, turmeric, and some of the colored petals. சில ஃப்ளார்ஸ்ல இருக்கிற கலர் பெட்டல்ஸ் கூட அதோட சொல்யூஷனா எடுத்து we can use it as an indicator. There will be a color change. Okay, so we can remember these names as well. We will be calling them as indicators. இல்ல specify பண்ணி சொன்னாலும் sometimes acid base indicators னு கூட இருக்கும். Okay, and what is the one more type we have learned other than natural indicators?
Synthetic.
Synthetic.
Yes, synthetic indicators. Can you name any of these synthetic indicators? Any one of you? Rohan, Harish? Any
No,
idea? No.
no, ma'am.
Okay. Yeah. So synthetic, what do we mean by this term first?
It is
By using
man-made.
artificial.
Yeah. So it is, yes, man-made.
Artificially used to indicate something.
Yes.
Indicate.
So this is an indicator which is artificially prepared from the laboratory. அந்த மாதிரி இருக்குது. நேச்சுரலா இருக்கிற சப்ஸ்டன்ஸ்ல இருந்து எடுக்காம இவ்வளவு நேரம் நம்ம பார்த்தது எல்லாமே இட் இஸ் நேச்சுரலா லீவ்ஸ்ல இருந்து எடுக்கிறது, ஃபிளவர்ஸ்ல இருந்து எடுக்கிறது, அந்த மாதிரி தான் பார்த்துருக்கோம். கரெக்டா? So here it is a synthetic indicator where we can use two things. One is called as phenolphthalein. The name of the indicator is phenolphthalein. The other one we can use it methyl orange. Labல இண்டஸ்ட்ரீஸ்லாம் they will be using these kind of indicators. One is called as phenolphthalein, the other one is methyl orange. Okay, so these are the two indicators we have actually. So this phenolphthalein, it is actually colorless in acids and it is red, the pink color in base. The methyl orange, it is red color, it turns to red in acid and yellow in base. So these are the color changes for phenolphthalein and methyl orange, which is the synthetic indicators. Okay.
Yes, ma'am.
Yes. So let's do an activity now. We have various samples. இப்போ நீங்க ஒரு லேப்ல வந்து நீங்க இருக்கீங்க, ஓகேவா? இமேஜின் லைக் தட். நீங்க ஒரு லேப்ல இருக்கீங்க, உங்களுக்கு இந்த மாதிரி சொல்யூஷன்ஸ் கொடுக்குறாங்க. அது என்ன சொல்யூஷன் தெரியல, பட் இப்போ நமக்கு அந்த சாம்பிள்ஸோட நேம்லாம் இருக்கு. You are going to say how the color change will be. Have you all noted the color change for all the indicators? Yes. Okay. So So let's try that. Yeah. So we have first hydrochloric acid. So on the name lay namakku vandu irukku, correct? So you know it
from
is a
blue to red.
acid.
Colorless.
Yeah. When we use red litmus paper, how it turns?
It stays red.
It remains the same. There is no change, correct? Red litmus use panna red da. And if you use blue litmus paper,
Red. It turned red.
yes, it turns to red. And what if we use phenolphthalein?
It's colorless.
Colorless. Very good. And methyl orange? Sorry?
Pink.
Pink. Pink color? Okay. Is that the color we have seen? Everyone is sure with that?
Orange, ma'am.
Orange. Where are the other colors? Okay, let me show you one more time. It is like or orangish yellow color base red acids red. Okay, it is red. Pinkish red in kuda neenga solla, but red color you can choose. Okay, so from the given substance you should able to identify which is an acid and a base. Appdi irundhuchna easy ah namu kandupidichidalam. So we have HCl and H2SO4, HNO3, and then CH3COOH. So what is the main thing we know for acid?
They have
Acid, yes, they will release H plus ion. So we can easily find out hydrogen. So this is one of the way to find. But in the compound la parunga, for bases we know it should have
OH minus ions.
OH minus ion, correct? So here you see, you can see OH, OH, OH. So we can call them as bases, right? Ana in the last idula eppadi irukku? Will it be an acid or a base?
Maybe neutral, ma'am.
Maybe neutral. Okay. Any other guess?
Or salt.
Yes.
Salt. Okay.
Acid.
Acid. Acid. Yes. So first question la we have seen, right? You said it is acidic acid. Do you remember that? Yes. So it is actually acidic acid. This is, yes. This is the acidic acid. Why? Because when we dissolve them in water, it actually breaks down like this. Okay. So you can see, enna ion release aayirukku? H plus
H
or
plus.
H minus? H plus. So we can say them as acid. We have various types. That is, we will categorize acid as weak acid or strong acid. I will let you know one more time in that type as well. Okay. So this is it is considered as an acid. Okay. And also remember that not all hydrogen containing substance we will call them as acid. இங்க ஹைட்ரோஜன் இருக்கு அதனால ஆசிட் அப்படின்னு கிடையாது. ஓகேவா? So எல்லா இப்போ for example you can take this compound as well, or yeah, you can take this C6 glucose. You have learned, right, in photosynthesis reaction.
Yes, ma'am.
Can anyone say its formula? Do you remember that?
C6 H12O6.
H12O6. Even here we have hydrogen, correct? But this is not an acid. Okay. So not all hydrogen containing substance is acid. The substance which is going to produce H plus ions, we call them as acid. Be clear with that. Okay. H plus ions, when you dissolve it in water, if it is producing the H plus ion, only then we can consider them as acid. Hydrogen irukku adanal acid அப்படின்னு நம்ம வந்து சொல்ல முடியாது. Okay, we cannot call them as acid. Am I clear to everyone?
Yes, ma'am.
Yes, ma'am.
Yes. Okay. So remember this. And இப்போ இங்க கொடுத்திருக்கிற ஒவ்வொரு samples, first you said for acid. Now we will try for base as well one more time. So we have sodium hydroxide, right? NaOH, which is a base. Tell me how it will be for red litmus. If I take red litmus,
It changed to blue.
it changed to blue. In case of blue litmus,
Blue.
yeah, blue. So there is no change of color, any color. Phenolphthalein,
Pink.
pink. And methyl orange,
Yellow.
red or yellow?
Yellow.
Yellow.
Yellow. It is a base, so it turns to yellow. Okay. So this is how it is. You can see here. For all the samples that is given here, If it is an acid, when you use red litmus paper, there is no change. When you use blue litmus paper for acid, it changes to red color. Correct? So all the acids changes to red color. Similarly, when you use it in phenolphthalein, it is colorless. So all the acids are colorless. In methyl orange, it is red in color for acids. And the same applies for base. So கீழ எல்லா சப்ஸ்டன்ஸும் பேஸ் இருக்கு, OH இருக்கிறதுனால நீங்க அப்படி ஞாபகம் வச்சுக்கலாம். ஹைட்ராக்சைடு, the naming will also be hydroxide. So if it is a base, red litmus paper changes to blue color. If it is a base you are using in blue litmus paper, there is no change, right? And phenolphthalein, it changes to pink, and methyl orange changes to yellow. Yes, Harini?
Ma'am, now in phenolphthalein, the natural color itself is colorless,
Normal,
Oh.
yes.
or does it have any color, ma'am?
No, it doesn't have any color. Okay.
Okay.
So it is actually a colorless solution. Only in the, actually it is a colorless solution, phenolphthalein. It remains colorless. So based on the
Okay.
substance you are taking, it changes. The color of the substance will change. Okay.
Okay.
Yes.
Okay, ma'am.
Okay. So that is the thing. And methyl orange க்கு color இருக்கும். Phenolphthalein வந்து colorless தான் இருக்கும். அது acidicல நீங்க ஆட் பண்றீங்கன்னா அதுவுமே அப்படிதான் இருக்க போகுது. பேஸ்ல ஆட் பண்ணும்போது பிங்க் கலர்ல சேஞ்ச் ஆகும். ஓகே. பட் மெத்தில் ஆரஞ்சு இட் இஸ் ஆரஞ்சு கலர்ல இருக்கும் அந்த சொல்யூஷன். கொஞ்சம் நல்ல ஹெவியா அந்த ஆரஞ்சு நல்ல டார்க்காக ஒரு மாதிரி ரெட்டா சேஞ்ச் ஆச்சுன்னா ஆசிட். இப்ப நீங்க பேஸ் எடுத்து ஆட் பண்றீங்கன்னா அந்த ஆரஞ்சு லைட்டர் ஆகி எல்லோவா சேஞ்ச் ஆகுற மாதிரி. ஓகே. எஸ். So shall we try to frame organize all these we have learned indicator. இப்ப பார்த்த indicator எல்லாமே ஒரு டேபிள்ல போடலாமா? You are going to say me. Shall we do it for
Yes, ma'am.
making easier ஞாபகம் வச்சுக்கிறதுக்கு? Yes. So starting from the litmus paper, how it will be? For acid, எந்த litmus paperல color change இருக்கும்?
Blue to red.
Very good. So blue litmus paper will turns to red. For base,
Red.
Litmus to blue.
yes, red litmus paper will turns to blue. Neutral இருந்தா there is no change,
No
right?
change.
அந்த எந்த கலருமே எப்படி இருக்கோ அதே கலர்ல தான் இருக்க போகுது. For phenolphthalein, acid,
Colorless.
it is colorless. And for base, red, pink in color. Okay. And methyl orange,
Red.
yes, in acid it turns to red color, and in base
Yellow.
Okay. Slightly color வந்து கொஞ்சம் கம்மியாகும், lighter colorக்கு வரும். So this is how the changes. Any idea about neutral solution, how the phenolphthalein is? It is colorless again. Okay. Phenolphthalein, it is colorless in neutral solution. It remains colorless தான் இருக்க போகுது. And methyl orange,
A bit
Remains orange.
shaky.
orange. Okay. So even இது mostly methyl orange, it will be like slightly light color, yellowish அந்த மாதிரி கலர்ல தான் இருக்கும். ஓகே. ஸோ நியூட்ரல்ல இருக்க போது அந்த ஆரஞ்சு எல்லோ அந்த கலர்ல தான் மோஸ்ட்லி இருக்கும். பட் மோஸ்ட்லி வி won't try for neutral solution. We will testing this mainly for to find out whether it is an acid or base. Okay.
Book a free demo class and join Pumpa to make your children toppers.